In this video, we will talk about graphing polar curves. So I will post this little picture on Canvas. It's not the best picture, but I really like this because it kind of gives you a little gist of the common polar curves. I'll speak a little bit about them first, and then we'll try to graph some of them. I personally don't memorize this. I just graph it and just do it. But I think one thing that kind of helps me, or I think will help you, is if you were able to kind of just look at the equations and just kind of have a gist of what it kind of looks like. I think you would be pretty good. Usually in if for Calc 2, I there will be maybe I might have to ask you, oh, draw a rose curve. But for the most part, most of these graphs are going to be given to you in a problem, and you have to find the intersection between two different polar curves. Like if I have a rose curve and a circle together and you want to find certain areas, that's basically what I would probably have to ask you. But other than that, I want to be able to make sure that you know how to graph them anyways, because they are very, very important. So, first, we'll start off with the circle and the spiral. So, a couple of things about the circle. We've already established that if you have r is equal to like maybe 3, okay, this is just a circle of radius 3, okay, regardless of whatever the angle is. So that one's just pretty basic. And then you kind of have the circle, but now instead of just having a value, now we're applying a sine or a cosine. So basically, if you were to apply a sine next to the a, so let's say you have r is equal to 2 sine theta, okay, then basically what it'll do, it'll give you a circle that's kind of like hinged around the pole. So if you see the pole is here, here's my pole. And then basically what it's doing, the circle is being hinged on the positive axis in the y direction. And one thing that kind of reminds me is that the sine is basically the y coordinate in the unit circle. So you basically are hinged there, and then you just have a circle of radius 2. With the cosine, however, if you had maybe r is equal to 2 cosine theta, you still have the same circle. You have the pole there, and it's hinged next to the pole, but it's now on the positive x-axis. Okay, so one way that I remember it is that the cosine is the x value in the unit circle, so it's just going in the positive direction. If this was in the negative direction, then it would be on the bottom part of the y-axis, on the negative side. If it was a negative 2 cosine theta, and then it will be on the negative x-axis. Okay. So something to kind of just be aware of. Then the spiral, basically, you kind of are eliminating the cosine or the sine, and you're just having r is equal to 3, and then you're attaching it to a theta. And this is just going to be just a little spiral. Okay, it's just going to be spiraling around. That's basically it for this one. Here, we have the Limacons. So the Limacons are I never remember these. I always mess them up. So I just graph them. I don't even remember this. For me, this is annoying. It's just confusing. I mean, if you have a photographic memory, I'm sure that you'll be able to figure it out. I don't. I like seeing it. And usually when I graph these curves as a reference, I will remember if it's looping or not, if you have a limacon or if you have a cardioid. So basically, here it's saying if you have this type of form, and notice that the sine and the cosine are still the same. So I think all of these are sines. If they were cosine, obviously they would be hinged around the x-axis. But basically what happens is that if you see the value of a being less than b, then you're going to have this little loop thing, okay? Now, you have to be very careful when you draw these things, because just drawing them however is not going to be enough. You have to make sure that you know at what angle is this loop going to. If a is equal to b, then you have this little, it's kind of like a little heart, okay? It's called cardioid. So have your little heart. If a now is greater than b, then you have this dimple, okay? Limacon. and then you have this convex limacon. It was twice. I don't remember this at all. I just go ahead and do it. I know that it will be one of these guys, and when I graph them, I'll be able to figure out which one loops and which one doesn't. For the rose curves, basically the only thing that's different about the rose curves comparison to everything else is that you have a coefficient on in front of the theta of the trigonometric function. If n is odd, you're gonna have n leaves, and if n is even, you're gonna have two n leaves. So for example, see how 2 is an even number, so you're gonna have 4, so twice as many. 3 is an odd number, so you're only gonna have 3. Um, Something to also know is that the cosines, just like how we said before, they're always hinged around the x-axis. So you can see that the rows, the petals are all going to be around the, or at least starting will be around the x-axis. However, with the sines, they're going to be on the off sides. So you have to be very careful with these problems because you can see that cosines, they might be alternating. It's you have to just draw them. I don't follow this chart. I think it's just useful. And then you have the Lemonscates. So these the way that I remember them is that you have an r squared. Okay, so you kind of have like this figure eight. Okay, so what I'll do is that I'll do a couple of problems to kind of show you how to graph them. I think giving you that tool is really useful. And the way that we graph them, I'll give you a little disclaimer, is this is how I like to do them. Obviously, if you watched another video or if your teacher taught you a different way, do it that way. But this is the way that I like to do it, the way that makes sense to me. So hopefully it will make sense to you also. But there's not one right or wrong way to do it. But I prefer this way. So we're gonna first start off with the spiral. Okay, so we'll start off with spirals. Okay, so let's start off with the spiral graph. And let's say we want to graph r is equal to 2 theta. Okay, so we want to be able to graph something like that. So the first thing that I like to do is draw something called a reference graph. Okay, reference. And basically what the reference graph does is that I just graph this in regular x and y. So in this case, my y would be my r, and my x would be my theta. And what I'm going to do is I'm going to just plot points. Now, theta remember, it's my angle. Okay, so what I'm going to do is I'm just going to plot random points. I'm going to plug in 0. I'm going to plug in maybe pi over 2. I'm going to plug in maybe a pi, 3 pi over 2, 2 pi. Okay, I'm just going to plot these random points. Okay, and then I'm going to plug them in to my r function. So when I plug in pi over 2 in here, I'm just going to get pi. Okay, so I'm just going to get, I don't know, pi. So at pi over 2, I'm going to get pi. Then at pi, I'm going to get 2 pi. And when I plug in 3 pi over 2, I'm going to get 3 pi. Okay. And then when I plug in 2 pi, I'm going to get 4 pi. So you can see that this is kind of increasing. And I forgot to plug in 0, but you get 0. So you can kind of see this straight line. Okay. So it's just increasing, increasing, increasing. Okay. You're adding pi every single time. Okay. So what is this going to look like? So if you remember what pi is about 3.14. So you can kind of try to estimate these points. So if pi, this is 3.14, about, if I put 2 pi, this is about 6.28. 3 pi, that's going to be about 9.42. And then 4 pi, that's going to be about 12.57. Okay, so I think that will be a little bit easier to kind of see. So the way that I'm going to do it is I'm going to do kind of the same thing as I did before. Okay, so here is kind of my graph, my x and y, but this is now going to be the polar curve. Okay, and the way that I do it is, remember that this is theta are my angles. Okay, and the way that I do is I always start at the pole. Okay, so I'm going to start off with theta. So here's theta equals 0 radians. So at theta equals 0 radians, you're just at the pole at 0. Okay, so here you're there. So you always want to start there, start at the pole, and I stay there because at theta equals 0, I stay there. Now at theta equals pi over 2. Okay, so at pi over 2, so basically theta equals pi over 2 is 90 degrees. So in this direction, okay, what is the value? Well, if that direction is at pi over 2, it's going to be pi, which is 3.14. So 3.14 is like 1, 2, 3, and then 3.14 is around there. Okay, so that's where it's at. So think about it's kind of going from theta equals 0 all the way to pi over 2. So theta equals 0 all the way to pi over 2. Oh, maybe make it a little bit better. So I'm going to be kind of going this way, and then I'm going to hit there. Okay. Then at pi, so pi is going to be over here. At pi, you have 2 pi, and that's going to be 6.28. So at pi, okay, so in this direction, okay, so remember, this is still the polar. So at the theta equals pi, you're moving 6 units in that direction. So 1, 2, 3, 4, 5, 6.28. So you're moving 6.28 units. Okay, so let me draw it a little bit better. Okay, so it looks like this. Okay, so 6.28. Okay, we're right there. Okay, so notice that you kind of have this curve. Okay, because you still have all of these other angles that I didn't check. Notice that at pi over 4, I still have something. Okay, so at pi over 4, you do go somewhere. Okay, then we're going to go to 3 pi over 2. 3 pi over 2 is going to be right here. And at 3 pi over 2, you can see that my R value is going to be 9.42. So at 3 pi over 2, I'm going to go down to 9.42. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here's 10. So 9.42 is around here. So then from here all the way there, I'm just going to continue. Okay. And then at 2 pi, theta equals 2 pi, I'm going to be at 12. Okay, so theta equals 2 pi is in this direction. So I'm going to go to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to go all the way over here. So you can see that this is kind of just spiraling over and over and over and over. Okay, so this is a really good way to kind of just do it. Now, the first time that you do try to graph these is going to be a little bit weird because we are not used to graphing these types of graphs like this, but this is basically what you're doing. Okay, so that's the spiral. So let's do the next one. Okay, so let's say we want to graph r is equal to 2 sine theta. Okay, so this is going to be the circle. Okay, so the first thing that I'm going to do is I'm going to graph r equals 2 sine theta using the reference graph. Okay, so to graph the sine curve, you just have 0, pi over 2, pi, 3 pi over 2, 2 pi. You can see that this has an amplitude of 2. And then remember, sine always starts at 0. And then you just graph. Okay, so the basic sine curve. Okay. All right, so now what we're going to do is now, this was the Cartesian coordinate. Okay, pretend that this is the x and y. Now we're going to graph it in the polar. Okay, so now the polar curve. So we're going to do kind of the same thing. And if you kind of think about it, what I'm going to do, you can kind of see that the radius is going around 2. Okay, so you can see that the radius is a maximum of 2. So if you want to think of a circle of radius 2, right? So here's a circle of radius 2. This is basically what this is kind of like, you can kind of think about that you are not extending from a circle of radius 2. So like you technically don't need polar paper. You can just say that this is a circle of radius 2. This is where I'm going to be at. Okay. So if you wanted to write polar paper, you can. Obviously, you don't need to do this if you don't want to, but you can keep it like this. Okay. So maybe this is just 1 and 2. I don't know. Okay. So now what you want to do is you want to start off with always the pole. Okay, so let's start off with the pole. So here, here's the pole. Okay, so the first thing that it says is that theta is equal to 0. Okay, theta equals 0. So theta is equal to 0. What is my radius? My radius is just 0. Okay, so that's just going to say a 0. So I'm going to put a point there. All right, then it says at pi over 2. Theta equals pi over 2. That's this guy. Theta equals pi over 2. So theta equals pi over 2. I'm going to increase. So I'm still increasing. And then slowly decrease until I get to 2. Okay, so I'm going to increase until I get to 2. So remember, this is a circle of radius 2. So I'm going to increase from theta equals 0 all the way to 2. So I'm going to go here. Okay, at 2. Then at theta equals pi over pi, because that's the next angle, theta equals pi, what is it doing? So now you're decreasing until you get to 0. Okay, so you're going to decrease until you get to 0. Okay, so at theta equals pi, you're going to go to 0. Okay, all right, then you're going to go to 3 pi over 2. Theta equals 3 pi over 2. So now you're looking at this line. Okay, remember that we stopped here. The angle, or I'm sorry, the radius is going to be -2. So that means in this direction, it's going to be positive radius. We're right here right now. So going opposite is going to be negative. So I'm just going to go back. So notice that at this point, you're just tracing the circle again. Because then when you go back to pi over 2, you're going to go to 0. So when you go back to pi over 2, you're going to be here, go back to 0. So basically what you're doing is you're just tracing the circle around. So this is going to be my polar curve. Of course, you don't need to draw all of these extra little markings that I have in the background. If that confused you, you can just get rid of it. You can just kind of just eye it. But if you wanted it to do it in polar paper, obviously you can just, it'll be easier for you to figure out where exactly radius 2 is. Okay. All right, so this is a circle. Okay, if I were to draw the cosine, it would just be on the side. Okay, so now let's do another problem. So this was for the circle. Okay, now let's do one with a cardioid. Okay, so let's say we had r is equal to 2 plus 2 cosine theta. Okay, so basically we're going to try to graph something that kind of looks like this. Cardioid, when a and b is equal to each other. Okay, we're going to see the other one for last. Okay, so the first thing that we're going to do is we're going to graph this. Okay, so the first thing that we're going to do is this is going to be, we're going to start off with 2 cosine theta. So this is going to be 2 and 2. Okay, so my amplitude is 2 and 2. And then cosine is going to start at the very top. So everything is going to be the same. The period hasn't changed. So pi over 2, pi, 3 pi over 2, 2 pi. Cosine is going to start at 2. And then we're going to just fill in the points for the cosine curve. Okay, now notice that I'm not done yet because now you have this positive 2. So now what we're going to do is shift the entire graph up 2 units. So everything's going to have a plus 2. So now my graph is going to look like this. So everything's going to go up by 2 units. This stays the same, pi over 2, pi, 3 pi over 2, and then 2 pi. And then let's go ahead and graph. So this is now going to be at 4. Lift this up, this is going to be at 2. Lift that up, that's going to be at 0, then 2, and then 4. Okay, so I'm going to have this curve that kind of looks like this. All right? So I just shifted the whole cosine curve up 2 units. So now what we're going to do is we're going to try to draw this, this cardioid. So the way that we're going to do it is the same way that we were doing the other 2 problems. So we're going to first start off with my polar. So I'm going to write polar curve. So my polar curve remember that we're always starting off at the pole. Okay, so have this. So here's the pole, all right? And now we're gonna take theta to be equal to 0. So remember, we're starting at 0. Theta equals 0, okay? At theta equals 0, what do we have? At theta equals 0, we start off with the point 4. 1, 2, 3, 4. So in this direction, theta equals 0, we're starting at that 4. Okay, we're staying there. Okay, that's where we're going to start. Theta equals 4. Okay, so if you can think about 4 different circles of radius, then you have the 4th circle, which is the radius 4. This is where we're going to start. Okay, that's this one. Remember, this is theta and this is r. Okay, now what we're going to do, we're going to go to theta equals pi over 2. Theta equals pi over 2. So at theta equals pi over 2, what is the radius? The radius is going to be 2. Okay, so it's going to go up 2. Okay, so notice that in this direction, here's theta equals pi over 2, and you're going to go up 2 units. So I'm going from this guy, from 4, all the way to 2. Okay, so all the way until we get to 2. Okay, now my next point is going to be pi. So at theta equals pi. So theta equals pi, what do I have? Well, I have a 0. Okay, so in this direction, at theta equals pi, okay, in this direction, I'm going to go 0 radius. So 0 is just a pole right here. Okay, so now I'm going to go from 2, because I ended up at 2, now I'm going to go to 0. So it's basically decreasing until I get to 0. Okay. All right, and then after that, we're going to go to 3 pi over 2. So theta equals 3 pi over 2. It's right here. And at 3 pi over 2, notice that in this direction, we're going, radius is going to be 2. 1, 2. Okay, so I'm going to go from 0, because I started at 0, back to 2. Okay, and then I'm going to complete it until I go to 2 pi. Theta equals 2 pi. So then I start going from 2, I'm going to go up to 4. So I'm going to end it like that, at 4. So you kind of see like this funky looking heart, okay? So I personally like this reference graph. Obviously, you can plug in points too. That also works. I like graphing it. I think also students need help graphing anyways, trig functions. So I feel like this is a little useful, okay? All right, now let's do a limacon. Okay, so let's try to graph a limacon. Okay, so let's say we have r is equal to 1 plus 2 cosine theta. Okay, so here's where you really want to be careful with these types of problems. Okay, so a limacon, remember, you'll get one with a loop. So if we go back up, you'll see that the one with the loop right here is when a is less than b. Here's a and b, right? So basically your how much you're lifting it up or down is much smaller than your amplitude. So notice here that you're lifting it up 1, but it's much smaller than your amplitude, which is 2. So let's take a look at what that looks like. So remember, this is your theta, and here's your r. I'm going to start at 0, pi over 2, pi, 3 pi over 2, 2 pi. My amplitude in this case is going to be 2. And then I'm going to graph the cosine, which starts at the very top and then just continues. Okay, so this is basically the curve without shifting it up. And now I'm going to shift it up 1 unit. So I'm going to plot this again, up 1 unit. Here's theta and here's r. So shifting 2 up 1 unit, I'm going to be at 3 pi over 2, pi, 3 pi over 2, and then 2 pi. if I shift up pi over 2 from 0 up to the next one, is going to be at 1. Okay. Okay. Then at pi, notice that I was at -2. I'm going to shift it up 1. Now I'm going to be at -1. 3 pi over 2, I was at 0. Lift it up 1. I'm going to be at 1 now. And then at pi over 2 pi, I'm going to lift it up 1 unit, and I'm going to be at 3. Okay, so this is what my new graph looks like. Okay, that looks kind of weird. Oh my god, that was worse. Okay, anyways, I don't care. All right, so no. Okay, this is a little better. Okay, it doesn't matter. Okay. So notice a couple of things. So there's a couple things that are going on here. And really what you want to really take a look at is things are happening between pi over 2 and pi and 3 pi over 2 that may not seem that's very subtle. You can see that between pi over 2 to pi, the graph goes to 0. And also between pi to 3 pi over 2, the graph also goes to 0. At some points that are not in the tick marks. You can see that in the previous problems, whenever the graph went to 0, we knew what the points were when it went to 0. Even over here, we knew what the points were when it went to 0. However, here, we don't know what they are. But we know that it's somewhere between pi over 2 and pi and 3 pi over 2. And obviously, we can figure it out by setting r equal to 0. But it's not necessary. So we have to take that into consideration. So let's go ahead and graph this. Okay, into my polar curve. So now we're going to start off with theta equals 0. So here's 0, theta equals 0. And at theta equals 0, you can see that the radius is going to be 3. So in theta equals 0, this is going in this direction. My directed distance is going to be 3. 1, 2, 3. That's where we're going to start. So starting from the pole, you're going to go up to 3 units. Okay? Then after that, at pi over 2, okay, we go up one unit. Okay, so in this direction, you're going up 1 unit. Okay, so basically, this looks kind of like this. So you start at 3, and now you're going to go to 1. Okay, going to go to 1. Okay, in that direction. Now notice that right before we go to pi, it goes to 0. Okay, at some unknown angle. So at some unknown angle, I don't know what that angle is, but at some angle, right, wherever this is, at this angle, you're going to go to 0. So at this particular angle, okay, remember, in this direction, this graph is going to go to 0. So from here to here, you're going to go to 0. Okay, so you go to 0. Okay, then you're going to go to pi. Okay, so now you have theta equals pi. So now we pass the 0, and now we're going to go to pi. Theta equals pi. And at theta equals pi, notice that my directed distance is -1. So remember, this is the distance, the positive distance in the pi direction, and theta equals pi. But remember, all of these values are positive. So the -1 is going to be in the opposite direction. So this is still pi. This whole line is still pi. Here is the pole, here's 0. All of these are positive values, but we don't want the positive, we want the negatives. So we're going to go back to -1. So from here, because this is where we left off, we're going to go to 1. Okay? Then notice that you're going to go past that angle again. So you're going to have that angle one more time. Okay? So this angle, that I don't know quite what it is, which is this guy, is going to go back to 0. Okay? So at this particular angle, whatever that may be, I'm going to go back to 0. So from here, in this particular angle, I'm going to go to 0. Back to 0. Okay? And now I'm going to go to 3 pi over 2. At 3 pi over 2, theta equals 3 pi over 2. in this, so this is the direction, what is going to be my radius? My radius is going to be 1. So I'm going to go 1 unit in this direction. So I started at 0. I'm going to go back 1 unit. Let me get rid of this. Looks weird to see. Okay, and then finally you're going to go to 2 pi. And at 2 pi, the radius is 3. From there, I'm going to go to 3. So you're going to go to 3. So you see this curve, or this limacon that has this loop. So I think the thing that you got to be careful with is just these guys. Okay, be careful when it crosses the 0. Okay, now let's do some of the rose curves. Okay, so some of the rose curves, some of them can be really, really hard to do. So we'll do a couple. So let's say we wanted to graph r is equal to sine 2 theta. Okay. Now, one thing to kind of note is that before, everything was from 0 to 2 pi because there was no change in the theta value. But in this case, you have a 2. Okay, so one way that I kind of like to do it, or one thing that you can try to figure out, is try to figure out what the period should be. And one way that you can figure it out is taking 2 pi divided by b, where b is a number that's right next to it. Okay, so 2 pi divided by b, okay, in this case, b is equal to 2, so it'll complete one period in pi units. So basically, when you graph this, so here's r and here's theta. Instead of going from 0 to 2 pi, it'll go from 0 to pi. And all you got to do is find the midpoints between them. So the midpoint between 0 and pi is pi over 2. The midpoint between 0 and pi over 2 is pi over 4. And the midpoint between pi over 2 and pi is going to be 3 pi over 4. Okay? Notice that there's no amplitude, so it's just going to be 1 and 1. And now we're just going to graph this curve. Okay, so we're going to start off at 0, then 1, 0, -1, 0. Now, typically what I like to do is I like to continue on because sometimes it's not going to give you everything. Okay, so notice that everything's going by pi over 4. So I'm going to continue to add pi over 4. So it's going to give me 5 pi over 4. Okay, so I'm adding pi plus pi over 4. That gives me 5 pi over 4. Okay, then you're going to get 3 pi over 2. Then you're going to get 7 pi over 4. And then you're going to get 8 pi over 4, which is going to be 2 pi. Okay, so you can just continue until you finally get the 2 pi. So then you can kind of see that the sine curve, okay, is going to continue. Okay. And the reason why I'm doing this is because you'll see why. Okay. So now let's draw the rose curve, the polar curve. Okay. So we're going to start off with theta equals 0. So theta equals 0. You can see that we have 0. Okay, so we're going to stay there. Then we're going to go to theta equals pi over 4. So theta equals pi over 4 is around here. This is 45 degrees. And sometimes if radians kind of scare you, you can do it in degrees if you want to. So theta equals pi over 4 is right there. And then what you want to do is you're going to go from 0, starting here, all the way to 1 unit. Okay, so if I just say this is 1, okay, then you can do it either above or below, doesn't really matter. And you're going to go over 1 unit. Okay, in that direction. Then you're going to go to theta equals pi over 2. So theta equals pi over 2. You can see that the radius is 0, so we're going back to the pool. So in this direction, you're going to go back to 0. Okay. Then you're going to go to theta equals 3 pi over 4. So 3 pi over 4 is right over there. Okay. theta equals 3 pi over 4. And in this direction, what are you doing? So in this direction, okay, you're going r equals -1. Okay, so this is the positive direction. So you're going to have to go the opposite way for the negative direction. Okay, and you're going -1. So if, for example, if this is +1 in that direction, this is 0, here's -1 in this direction. Okay, so here's -1. So we're gonna start, so we ended up here at 0, and now we're gonna go back to -1. Then lastly, we're gonna go back to pi, so theta equals pi. Okay, and then there you're just gonna go back to 0. So starting there, you're gonna go back to 0. Now notice that if we did not have this extra cycle, we would have had not the complete graph. Okay, we would have just had this, which is not what we want. We want to complete it. Okay, so now we're going to continue. We're going to now go to 5 pi over 4. So 5 pi over 4 is basically across from pi over 4. At 5 pi over 4, you can see that it's going to be +1. So at theta equals 5 pi over 4, it's just going to be 1 unit in this direction. So we stopped at 0, so we're going to go over 1 unit. Okay, so let me try to make this a little better. Okay. And then you're going to go at 3 pi over 2, that's just 0. Go back to 0, so here's theta equals 3 pi over 2. That's going to go back to 0. Okay. And then at 7 pi over 4, so here's theta equals 7 pi over 4. Okay. You're going to be at -1. Okay. So at -1, you're going to go back. So notice here is 7 pi over 4. Here are all the positive values in the direction of 7 pi over 4. But we want the negative values. The negative values are on the opposite side. So this is going to be -1. So we're going to start at 0, go back to -1, and then complete the circle at theta equals 2 pi. Okay. Okay, and that's how you graph them. And you can see that you have 4. So remember that it said that if this was even, this is going to just double. Okay. And then we'll do, so we'll do one more problem. And if you want in office hours, we can do more rose curves. But sometimes whenever you have the even ones, like 3 theta, like if you have cosine of 3 theta, what I would consider is that, especially because you want to have 2 pi over 3 as your period, it might be a little harder to kind of look at each of the midpoints. So what I would consider is maybe convert to degrees. Degrees might be a little easier for you to kind of look at. Okay. So then the last one that we would do is the Leminscate. Okay. So Leminscates. Okay. So let's say you had r squared equals sine of 2 theta. Okay. Now this one you have to be very careful with because you have an r squared. One thing that I would highly suggest is to not square root it, because if you square root it, that's going to look horrific to graph. So I would just, what I would do is I would graph this in just an r squared and a theta. Okay. So notice here, my period is going to be, again, 2 pi over b, which in this case is going to be 2 pi over 2, which is still pi. I'm going to go from 0 to pi. Halfway between pi is pi over 2. Then this is also going to be, oops, this is going to be pi over 4, and then 3 pi over 4. And then obviously you can do the same thing that we did before. So now in this case, we have to be very careful. So let me just continue writing everything else. 5 pi over 4, 3 pi over 2, 7 pi over 4, and then 2 pi. So here, notice that my amplitude is going to be 1. Okay? 1. Okay? This is for r squared. Okay? So now what you want to be able to do now is just graph it as normal. So we know what sine is. Sine is going to start at 0, and it's going to end one full cycle at pi. So it's going to be 1, 0, -1, 0, and then continues on again periodically. So it looks something like this. Okay. All right. So now we have to be very careful though, because notice that r squared here, this r squared, is only going to take positive values. It doesn't make sense for it to be negative. Okay, so basically all of these bottom ones, let me just write it like this instead. So you have kind of like this graph here. Then, so it's only, this function is only defined when it's positive, because when it's negative, notice if sine theta is negative, well, you can't have something that's negative. You can't take the square root of a negative number. So down here, it actually isn't defined. So not defined when sine of 2 theta is negative. Because remember, we're doing the square of that. And if we apply a square root to both sides, we're taking the square root of a negative number, and that just doesn't make sense. So basically, what you're only graphing is this guy, this blue part. The bottom part is really not there. Okay? So what does that look like? Well, let's draw our polar curve. Okay? So here, we're going to start at theta equals 0. You're going to start at the pole. Okay, so we're there. Then we're going to start at pi over 4. So at pi over 4, we're right here. Theta equals pi over 4. And we're going to go all the way up 1 unit. So 1 unit in that direction. Okay. Then at pi over 2, here's theta equals pi over 2. We're going to go back to 0. So back to the pole. Okay. Notice that from pi over 2 to pi, so from here, pi over 2, all the way to pi, there's nothing. Nothing happens. So now we're going to go from pi. Okay, so skip pi. Pi is at 0, stays there. Now we're going to go to 5 pi over 4. 5 pi over 4 is across from here. So here's theta equals 5 pi over 4. And in that direction is positive 1. Okay. And then you're going to go back to 3 pi over 2. And then you're going to go back to 0. And notice that after that, there's nothing there. So you kind of have like this figure 8 stuff. Okay, so kind of like, I mean, if I drew it a little bit better, it would make more sense. But this is basically what it kind of looks like. Okay, so this is what we call a Lemonscape. So all of these have different kinds of names, funky names, but this is kind of like a general gist of graphing them. So hopefully this kind of helped to give you a general view of how to graph these rose curves and cardioids and circles and on spirals and whatever. So again, this is just one way that I like to do it. Obviously, you don't need to do it this way. There's many other ways that you can do it. People usually plot points, they use symmetry, but for me, I feel like this is a little bit helpful.